All right, let's dive into something pretty wild today. We're looking at this really dense, fascinating idea that tries to connect modern physics, information theory, and, well, the ultimate nature of reality itself. The whole proposal suggests that the answer to one of the biggest questions we have is literally written into the code of the universe.
So it all kicks off with a puzzle that has bugged scientists and philosophers forever. I mean, really think about it for a second. Our universe isn't just a random soup of chaotic particles, right? It runs on these beautiful, elegant mathematical laws. But why? Why is there this incredible order instead of just static? This one question, this deep puzzle, is the launch pad for this entire incredible idea.
And this puzzle? It's our first big clue. The physicist Eugene Wigner had a great name for it. He called it the unreasonable effectiveness of mathematics. It's this strange, almost spooky fact that these abstract math concepts we cook up in our heads just happen to describe the physical world with mind-blowing accuracy. How is that possible? Okay, so the argument goes like this. Our universe is compressible. Think of it like a zip file. You have these few simple rules, the laws of physics, and when you unzip them, you get all the incredible complexity we see around us. Now, a universe of pure chaos would be incompressible, just random noise. The argument here is that a purely naturalist viewpoint that only the physical world exists often just treats this order as a given. But this proposal says, whoa, hold on. This very compressibility, that's a clue, a massive one, and it needs an explanation all on its own. So where do we even start looking for that explanation? Well, this idea suggests we need to look at one of the most fundamental things in all of modern science, information. Because, as it turns out, information isn't just some abstract concept. It has real, physical rules that actually govern our reality. And this right here is a really crucial point. For the longest time, we thought of information as, just an idea. But modern physics has shown us, no, it's a physical thing. It literally takes energy to erase it. It needs a physical form to even exist. It has real, tangible effects. Basically, information is just as fundamental to our universe as matter and energy. And these are the physical rules of the game. For instance, Landauer's principle directly connects information to energy. Deleting a file on your computer actually generates a tiny, tiny amount of heat. It's real. Then you have the Bekenstein bound, which puts a hard limit on how much information you can cram into any given space. And the holographic principle, well, that one's truly mind-bending. It suggests our whole 3D world could be a projection, with all its information stored on a distant 2D surface. These aren't just cool theories. They're actual physical limits that shape our cosmos. Okay, so with these physical rules of information in our back pocket, the proposal introduces a whole new kind of argument. It's not about what's in the universe. It's about the very structure that makes the universe understandable in the first place. And here is the core of it all, the information theoretic transcendental argument, or ITTA for short. Now, a transcendental argument is a bit of a fancy term, but the idea is simple. You start with something you know is true, like, hey, we can do science. And then you work backward to figure out what else must be true for that to even be possible. The ITTA argues that for science to work at all, the universe has to have a certain information structure, order, stable rules, boundaries. And here's the kicker, the system itself can't explain its own operating system. It's like trying to understand the rules of chess by only ever studying the wood the pieces are made of. You can't do it. The rules exist on a different level. Let's just walk through the logic real quick. 1. We can do science. Simple fact. 2. To do science, you need an orderly universe with stable rules. 3. This order isn't a given. A totally chaotic universe is a real possibility. 4. Now here's the twist. You can't use the tool of scientific explanation to explain away the need for the very possibility of explanation itself. See how that's a circular argument? And that leads to the big conclusion. The very conditions that make science possible have to come from somewhere. A ground, a foundation, that is outside the physical system itself. Now, this isn't just some dusty old philosophical argument repackaged. The key difference here is that traditional arguments, sometimes called tags, they usually focus on human logic or psychology or our minds. But the ITTA, it's grounded in hard physics. Its foundation isn't our thoughts, it's the measurable physical information structure of reality itself. So, okay, if this ground outside the physical system is real, could we ever find proof? Could we see evidence for it? This is where the whole idea shifts from abstract philosophy to a really fascinating empirical question. what would a signature of this ground even look like in our world? The proposal actually lays out 4 specific criteria. A signature would have holographic encoding, which is like finding 3D data packed onto a 2D surface. It would be anticipatory, meaning it would contain information that we could only understand with future technology, like a time-locked message. It would also be self-authenticating. It would have internal proof that it's not just a random fluke. And finally, it would seem to appear out of nowhere, without a clear physical cause. The author suggests 2 possible ways, or modalities, that a signature like this could actually show up. The first one is as a physical object, something tangible that gets inserted into our history. And the primary example given is the Shroud of Turin. Now look, setting aside the whole massive debate about its authenticity, the dissertation simply argues that it fits those predefined criteria. It claims the image has 3D data on a 2D surface, which is holographic. It claims that this data was only truly revealed with 20th century tech, making it anticipatory, and it argues that its unique features act as a form of self-authentication. The second way a signature could appear is totally different. It's not a physical thing at all. This idea suggests a signature could be hidden in the timeless, abstract world of pure mathematics. So for example, just imagine if we found a complex, clearly intelligent message buried deep, deep, deep in the digits of a mathematical constant like pi. It would totally be anticipatory, right? We'd need massive supercomputers to even find it, and it would be self-authenticating, because how could a message be embedded in a fundamental constant of the universe by any physical process within that universe? It couldn't. It would have to be a signature from outside the whole system. And now we get to the final, really elegant piece of this whole intricate puzzle. The proposal links these external signatures, both the physical and the mathematical kind, to the one place we can actually recognize them: our own consciousness. And this brings up a really fascinating question. I mean, think about it. The ability to decode 3D data from a weird old cloth or find complex patterns in transcendental numbers, that has absolutely zero evolutionary survival value. Our ancestors didn't need that to avoid being eaten by a tiger. So why on earth do our brains have the capacity to recognize these things at all? The dissertation calls this a structural correspondence. The idea is that our minds are weirdly mirrored to these signatures. The holographic encoding in a signature, well, that's reflected in our own consciousness, a rich, high-dimensional experience running on the physical hardware of our brain. The anticipatory structure, that's mirrored in our ability to plan, to imagine the future. And self-authentication, well, that's reflected in the most basic, undeniable fact of our own self-awareness. I think, therefore I am. So what's the end game here? What does all this add up to? The proposal takes these 3 threads, the physics of information, the cosmic signatures, and the structure of our minds, and weaves them into one grand, overarching conclusion about reality itself. It's a concept called informational eschatology. Now, eschatology is just a fancy word for the study of the ultimate destiny of things. So the idea here is that the fundamental ground of our reality is slowly, progressively revealing itself to us over time. But, and this is the crucial part, each new revelation is perfectly timed, perfectly calibrated to when our knowledge and our technology have matured enough to actually understand it. This timeline just makes the whole idea click. A potential physical signature, like the one argued for in the Shroud, only really becomes fully accessible once we invent photography and modern imaging. A potential mathematical signature would only ever be found in the age of supercomputers. And the very theory we're talking about, the ITTA, you could only even think of it once we developed information physics. The point is, the evidence seems to show up precisely when we have the tools to see it. And it all comes together in this one powerful idea, summed up by this quote from the proposal. As physics pushes further and further to the very edge of reality, with crazy ideas like the holographic principle and quantum information, it starts to describe a structure that seems to need something outside of itself to hold it all up. In this view, the scientists search for an explanation, and the theists search for a ground, start to look like they're converging on the exact same mystery. And that leaves us with one last, really provocative thought to chew on. This whole proposal basically frames reality as a kind of message, one that's slowly unfolding over all of human history. So, if the universe has its own language, written in the code of information itself, the question for us is, are we, right now, living at the exact moment in time when we are finally learning how to read it?